Hello, sir. Shall we start, sir? Nadul Singh, sir.
Yes, start.
So, very good afternoon to all. Now we have the next session titled Hydro and Tidal Energy Conversion with a special reference to micro level generation by Dr. Nitin Singh, sir, Professor in the Department of Electrical Engineering, NIT Silchar. It's my pleasure to introduce the guest for this session. Nitin Singh, born in Tripura, India in 1962. Sir has received a BE degree in Electrical Engineering from Calcutta University, Calcutta in the year 1984. MTech degree in Power Apparatus and Systems from IIT New Delhi in 1989. Sir received the PhD degree in Electrical Engineering from Jadavpur University, Kolkata. His PhD thesis was on application of intelligent techniques in optimal operation of power system. Since then, he has been engaged in active research in different areas like automatic generation control, optimal generation of power system under conventional as well as non-conventional environment, control of renewable energy sources and microgrid, image denoising, video motion estimation, EEG-based emotion detection, silent speech reading, etc. Sir has more than 100 national and international publications in diverse fields. He has been conferred with the senior membership of IEEE in 2008. He has successfully completed 4 sponsored R&D projects. Further, he has been the reviewer of number of international journals like IEEE, IET, Elsewhere, Taylor and Francis, and Springer, etc. Sir, it's a privilege to have you with us, sir. Let me request Professor Nitin Singh, sir, to take over the session. Sir, please.
Thank you, Dr. Srijit. Good afternoon. I think being that, that's so late for that, of course, I will not be going very much, what I should say that, see that what level technicalities we go for that there. However, I'd like to see that, how that, as an engineer, how do we land when we come up with, hydro and tidal energy conversion systems there. And more important one is that how as of now things happen and how where we were and how it is happening now and what will happen in future and what should be our motto, keeping in mind that green technology or sustainable life or something like that. So actually, as I said about that agenda, just like that means may not be that slides. I don't know how much it will be useful for that. I'll just give more stress on the technicality issues there. And different issues which are relevant, to understand as an engineer. You may talk about, or one may talk about so many hi-fi things there. Bottom line and coming down to that, as an engineer or practical aspects of that. What are the technicalities lies, and then where do we land in there, and where means do we have to that excel in the sense means what, that the technical part is there. Nowadays it has come up that one, that it has become very trend, that 70 to 80%, even more than that, researches are being carried out in simulation medium there. And whereas a person where he may have a number of publications there, even if he asks for that, forget about number of publications, even in the one publication in one circuit diagram with that only one system model, or how it has to be practically, there were the different perspectives of that same system being applied or being subjected to that one, how it will behave, or what are the different technicalities for that one is there. That is not much. Any sort of this, simulations and other things under different assumptions are there, which land up we people as an engineer to some of the what I should say pitfalls, maybe that one. So fundamentally something like that. But my only concern will be what I'll not go much about that. Okay, but technicality I will address to that one is there. It is a big area there when you go for the hydro resources there and hydro that energy conversion system there. and including that you have the tidal is there, or even ocean energy or other things there. It comes up for that. So I'll see that some of the that areas and others that converge together for both the type of energy conversion systems are there, and I'll try to end up my lecture on that what should be the directions in future days there ahead. Whereas all over the world, the developed countries, they have come up with lot more the research endeavors in coming out with what making this as a very potential that the scheme or technique, or we can say that one as idea to make that society sustainable. Because we have to that we have to, of course, that concept of that sustainability in society in terms of energy, and not only that one, when as a of course in a society that is very relevant. What we say about that comfortable life of a big industrialist like Ambani type of something like that. What is his feeling about that comfortable life, or what is the feeling of a person with comfortable life who resides in up in the Himalayan that mountains, or even hilly areas, or even islanded or something like that is there. The concept differs too much. And when we talk about that, that it is the job of the engineers to that meet the requirements, or making the that energy compliance sustainable way. So depending on that means what, that our objective has to that our journey has to start keeping in mind that what is my objective, what is our objective is there. The objective is the ultimate what giving that that sustainable energy to the society, and then again looking for that is there. Like that is what, like in the program we have come up with lot more topics there. Lot more topics are there which will take care of that issues related to that when we go for that sustainability of energy requirement there, or energy demand requirement that one is there. So anyway, so to come up for that is there. So I'll go for that. I'll go for a different type of the hydro sources. I'll just try to just touch upon that sources. These sources are there. Probably many of you will be also knowing that you go to that net or something like that to come up for that. Just it is a refresher of that that whatever things are there, and then lastly I'll come down to the technical part there. Okay, so please bear with me that for the time being that till we land up with the technical part there, and that the different type of projects are there also, that there is a different that classifications are there, or that is depending on that that varies actually person to person, or when estimates sometimes vary that the large hydropower projects, then small, then micro, thing like that is there. So it comes up for that is there. There is a okay. Anyway, I'll just see about that is there. So when we go for the actually that hydro plants are power plants are when they're classified ones based on what is the effective head. There are different way. One is that what is the type of head. Because why I want to make that this techniques or concepts are very relevant when we go for the technicality. That issues will be discussed at length, and keeping in mind that our objective of the sustainability, because that okay, that's so that depends on that one is that is very relevant for the effective head of the water there and available water head, and other one is what is the capacity of that is the rated output there. As we have seen the previous slide, that was the based on that some classification is made based on the capacities there. Then of course there may be classification based on the turbines. So okay, and other one is what there may be classification based on the location and type of dam and reservoir, etc. for that. That why this that I preferred this classification. When you classify that hydro projects or hydro power plants there, we say that one. So that classification may vary depending on that what is that fact in issue. It is whether it is what is the how much is the variation in the head of power there, how much is the water head availability of the water head. Other one is what is the capacity of that. of the hydro power plant is there. Capacity specifically, that of course it is a combination, so you come up with that. Sometimes it is argued for that is there, that or we can say that one that type of hydropower project, a power plant depends on that. These issues are kept in mind. Depending on that means what we come up with a design of hydropower plant. The question is what that yes, when we look for this 4 specific issues are there, keeping in mind this all 4 issues there, then you have to look for that how to come up with the design of a hydropower plant given that conditions in a particular locations there, so that like we can come up with develop a what we can design and develop a what very optimal that efficient effective hydropower plant there. Okay, so that may be there. But okay, this is very general concern is there. So same will be very important as we go for that, as we consider the different categories of that, that different issues will be there. And then same will be kept in mind when we go for that selection of the choice of that a particular technology. The choice of the technologies are there. And of course, the majority of what I'll say that some that this part is what the major component is that mechanical part there. You can have that not only mechanical or civil. Also, you have that one is the fluid dynamics one. And the fluid dynamics, or you can say that one is that fluid dynamics or solid dynamics. Specifically, fluid dynamics is very much important when we to deal with that one is there. Okay, so sometimes so in terms of head, we know that also that when the head is low head turbines are there, so 30 meter actually. Then there will be medium head up to 160 or 150. Sometimes that one, so it varies. And the head is what normally what to hover that no, it is above. It should be above 160 and up to about 1,000 meter there. That depends on that. So what. Once you go for the higher and higher head, that it is better. Actually, the more head, higher head, then what the potential, that also the hydro potential is what that water head and then how much is the amount of the flow is there. Both are important for finding that the power rated power of that plant there. So as we go on increasing the height there, particularly what that for the same amount of volume of water and same amount of flow, we can have very high power there. That is the concept that comes up for that is there. So anyway, so very important part is when we talk about the micro level generations there. So that means what specifically water head, which is what less than 30, not even less than 30. Why 30? That one is even still less, maybe that less than 1 meter also maybe there, or less than 2 or 3 meters also maybe that is important for that. That is really a challenging one. When you say the 30 meter is quite appreciable, that one is there. So because of that means that becomes challenging one. Then how that challenge is handled technically like that is that what all over the world different efforts are being made for that is there. This is what in terms of the capacity is there, as I said about that there. Okay, different again that value may vary there. Up to 30 or 50 megawatt and above is what normally a large hydro. Then sometimes what people talk about what that small means it comes under that mini whatever it is there. So it is what mini and the micro and the pico. That those values may vary. That values may vary depending on that. That of course a little bit of that one is there. So the pico that one when you have the pico level hydro plant is there. Then another one is what family level. That is what I said there. That we have to look for this type of things there. That the family level hydro generation is there, or hydro energy generation, or pico level hydro energy generation. Then micro level is okay if it is available. You see, there is nothing wrong if you have that more potential there. But there are issues. There are issues related to that. You go for the big project, hydro projects will be there. And we'll just discuss about that also. And many of you may be knowing about that, how that society is suffering. That one, say many things also do not get reflected in the newspaper or other items are there. It depends on that how importance of that. So this is okay. So this is based on the turbines there. When you have the different type of turbines are there, and normally we know mostly what these two type turbines are known. That one is the Francis is the reaction type turbine. Other one is what impulse type turbine is the Pelton wheel. Okay, the Pelton wheel, the bucket type that comes. So these two are there. Basically, that reaction type is there. but there may be there is a wide variations of this low head one. Low head one is there. There's all the different variations has come up for that that one because of the low head is there. And whereas high head there is not much there because you see that in the high head the only problem is what getting the water potential at the very high head. That is the main challenge for that is there. Whereas the main challenge is what so here that the low head there, how that the efficiency of the turbines can be improvised. How the efficiency of the turbines can be improvised at very low head. As low head goes down, then what that the efficiency, that ensuring the higher efficiency becomes a challenging one there. Okay, so that are the things that we'll just look for that is there. That part, some of the parts that will be the main issue in this case there. This is technical. When I say about the mechanical part, I'll just address to that one. And before I land up with the electrical part there, I'll see that one, how much time of that one is available for that electrical part there. Because this is important in the sense means what I expect, I hope that some of you, specifically young generation people there, that engineers, they will take up this one as a challenge there. Not only challenge. Why do you think that it is a challenge? Why do you think it is a challenge? You see that there are many issues, and then the problems that may give you the lot of patents will be there. Lot of patents there, and I don't think that it requires a lot of technical knowledge about that is there. Okay, technical knowledge is important when you go for the integration of these things there in the bigger systems. You go for that like microgrid or higher level of that one is there. But there are issues or there are problems which can be handled in a local level and islanded mode or isolated mode. But that comes up, that gives you as recognition or patent itself is what. Don't think that one just getting a journal paper itself will give you a PhD degree, but not a patent. No, the patent also may be considered as a qualification point for giving the PhD degree. So it is not the way. And above all that, of course, you get the direct recognition to that to the services given to the society there. Anyway, that is what one part there. And my ultimate, the objective is what to ignite your mind. For that means when you look for that, you look around. That all of you look around that your surroundings there. Look around the people who are at distress or something like that. I see that in front of me, suppose that you come up with that there are a lot of heavy rainfalls and leading to that lot of inundation, flooding of this thing and other like that is what. It doesn't mean that like look at that one, come out with a solution which will require minimum energy or energy available to the local side, and come out with a solution which will prove to be very, very efficient and very effective one, and it will prove to be a saviors of thousands of people. That is what my concern there. Of course, okay, technicality I have to relate it that when I go for that electrical part will be there. Anyway, so this is a different type of turbines given for that there. That as I said about that reaction type turbines there, and okay. Reaction type turbine is what that basically what it is a low head, and because of what when water is injected at high pressure, then it is made to pass through the blades there. So when it passes through the blade, then there will be decrease in the pressure, and that will result into the kinetic motions. Kinetic motions of the blades there, and then there will be series of stages will be there. Stage 1, stage 3, stage 4, stage 5 like this, stage 5 like this. So ultimately what that as the pressure goes down, there will be increase in that one in the kinetic energy there. So the pressure is converted into the kinetic energy. So energy available in the pressure in the form of pressure is converted into the kinetic energy. That is what. So that is how we come up for that is there. So means here head is not much important, because okay, how to ensure, how to increase the pressure of that water which is being given input or injected into the turbine or turbine blades there. So that is how, that means we can have even a runoff river or many other issues, other sources will be there where we can extract that, we can have that high flow of water which can be exploited to come up for that is what that conversion of that high flow water into mechanical energy or leading to that electrical energy there. Anyway, but the problem in this case is what that that as you go for that low flow is there, and there are a lot of flow also, there is wide variations of flow. When it comes up for the flow, when there is wide variations of flow, then output from the turbine also varies a lot. And not only with that one, with the decrease in the flow that one, then automatically that also the efficiency also drastically gets affected for that. With the lower speed, that efficiency goes drastically very less. Then when the high speed, okay, that one higher flow is there, then you come up with higher. So that creates, but the thing is they can cut you at 95%, that one is under optimal conditions there. That where the head maybe, as low as even 2 meter, even as high as even to 200 meter. Okay, that may be also that is there. That may be so. So basically that targeted for that low that head water head hydro resources there. This is what we say that one a Pelton wheel there, that is Pelton wheel, that impulse turbine there. That is what I say that you might have heard about that specifically electrical engineers there. So that the Pelton wheel, that when water is there, water is injected into the turbine blades through nozzles, through nozzles there. Depending on that, so nozzle is what it is, something like that hammering effect on the on the turbine blades. Blades will be like a bucket type. That one is there. So that the number of series of number of that nozzles will be used for impinging on that turbine blades there. Turbine blades, and that will result into rotational dynamics. So ultimately what this requires, so to have a very high force, impact force on the turbine blades, that requires that the nozzle has to be, the nozzle pressure has to be not the pressure, you have that water head has to be very high. The water head has to be high. So it is something like that we have in electrical engineering that high voltage is equivalent to that same as that water tank available, that at the higher height. The higher is the height, then that you come up with a pipe there, the more will be the pressure in the pipe. Same is the concept, is what higher is the voltage, the more will be the current flowing through that is there. So same in this case is there in that Pelton wheel there, impulse turbine. So ultimately what when at high head, the potential head, it is there, water is brought down to the lower one, then ultimately what, when that nozzle is created, so you are allowing the water to flow through a very small orifice there. That makes that one is very high impinging effect on the buckets there. So that is how this type of, so basically what this type of that the wheels or this effect is what very much useful when there is a high head available there. High head, but this is the first requirement. If the high head is not available, then okay, then what again, another one is what you may have to create another one concept is there, which is a new one maybe. Then one can create the increase in pressure otherwise like the artificially. That is a different issue. But natural requirement is what you have to have, that water resources which are at a very, very high water head, it is available there. So now the question is what, why this is important, why that this is not discussed nowhere or something like that is there. So but here that the volume is not much important, how much is that amount of flow is what not much important. Okay, but what is important is what high head there. So high head there. Now the thing is what the volume is important. Water volume is important because is that the volume will ensure about the continuity of the water, that potency, or we can say the continuity of the water supply. Sometimes what we'll see that one when people that go to the natural scenes or scenic beauties or like waterfalls and others, they start simply shouting about that. Oh, it is from so high, land is there, so much high is the height is there. So one can produce huge amount of that electrical energy there from there. Idle project can be installed. No, it may not be also viable. Why it is not viable? Then look for that. What is the source capacity of the source? Capacity of the source means what is the water volume available in that? Before that, in the upper reservoir, you can say about that. It is a natural reservoir. From there, water is made to fall in the waterfalls. So depending on the how much is the amount of volume required, that means one can decide that how much is the power, or basically it's not power, it is the energy which much is available. So continuity of that one, that power production can be ensured based on that. If the amount of volume is very, very insignificant, nobody can go for that. Is it? Okay, another one is one can create artificial reservoirs. That is what is done in the all big reservoir systems. big dam, the big reservoir system with a high dam, something like they come up for that one is there. Okay, so that is what it is done in the all big hydropower stations. But you know that also this type of hydropower stations, they prove to be, even fatal for that one, very much hazardous for the community, society also. In the case of what incessant rains that happened there in the Nepal, even China or something like that, it comes up for that is there. That creates havocs for that is there. Or suppose that because normally these water heads are available in the water head, these are to be created at the higher streams there, upper streams there. Upper stream means what in the hilly areas there, hilly terrains there. So normally you expect that in the hilly terrains you come up with that. Now busting of cloud. This is a very common incident there. If the busting of cloud happens to a reservoir, whether they're discharging, opening up all the blades of the dam will be in a position to save the dam or not. That is the question. So that even whole dam itself may be washed away. Just imagine what will happen to the downstream one. Whole cities, towns, and localities will be washed out. So these are the ways. This is one part. There is not many. There are many issues for that is there. Suppose, when you come up with a number of dams are there. So when there is a war is there. So that other country, enemy country, they did not have to, plant a bomb or the hurl a bomb at you or something like big bomb. Nothing is required. Simply, small bomb there at the dam site is likely to, damage so much to the society. So these are that we can have that one. So that doesn't mean that we should not produce energy. Yes, that is arguable. That is there. We have to produce energy at the same time means what you have to see for that what is the other alternative, means what complementary to that means what it should come out with what it should come out with some other that provisions there in the event of that some natural calamities or catastrophic incidents there, whether how much we can prepare ourselves or we can just come out with that or mitigate or solve that type of problems there. That is one part there. So okay, because we require the energy, but the thing is what that the high energy requirement is specifically for the industry sectors. High energy requirements specifically for industry sectors. We should so sustainability of energy means what? So we should be able to focus that or you can say that one is there whatever energy available from the conventional one, because hydro becomes also one of the conventional way of generating electricity, though it is the renewable one, but it is the conventional. So we should make that one, ensure that as less burden as possible to put on the stress on the that conventional sources for that sources of energy there, for electrical energy there. So that is possible only when what you come up with that other sectors there which are other than the industry part there that can be catered otherwise like that. Okay. So anyway, so why I said about this one that Pelton who is there, it is what, as I said about that, it is more dependent on the water head there. So and not much dependent on that is what, how much is the volume available there. The same concept also may be applicable for that, that you have a building there, 40-story or 30-story buildings there. Just imagine that 30-story building there, and with a what, because you see you have to come up with a design of a what, same type of Pelton one wheel-based turbine there. Okay, Pelton wheel-based turbine there, where means what, so what we can do is what we can store that all the waste waters, different waste water from all the flats in a particular one, next floor like there is there. So use that thrown away that disposable waters there and in a tank, and that same one will be made to flow through that one pipe is there, and the bottom line at the bottom of that ground floor you come up with it, use it, install your generators there before it is to be discharged to that one to the canals or the drainage systems there. Go for producing of that one, because head is quite high, only that what is that limitation is the water volume is less. So what, once you install it there, it's not big machine, it's a small machine there which can be, so one has to do the experimentation on that, means what, coming out with what Pelton wheel based turbine, and then converting that water, how much is the volume available at what height. And then other one is what you have that one is the Francis or reaction type. There are other turbines there is just today now we'll go for that is there some part of that. Just cover up, okay, maybe that. So some other type of turbines also just use the same type of, that coupler will be same thing there, machine will be same thing there. Only the thing is what turbine, type of turbine will be changed. That's all. So go for the experimentation and coming out with that, that how much is that, efficiency difference between the different type of schemes there. That is what. Anyway, that my concept was my purpose was that means what there is no tidal power station with very high head. Yes, concept is high head. So look for that wherever the that proportions for. Suppose you go for that Mizoram and Nagaland, some areas are there. So you can come up with so 100, 200, 500. This water head is not big thing there. From the top of that one, volume of water will be less. So simply use that one is there. That water made to flow through that flow through that one is at the ground of that one, ground level of that one. Then make that install the turbines at the down the stream or downstream of that one is there. Then automatically what you come up with that one's high we have electrical relevant because energy is converted into electrical form. We can do many things and almost tackle everything. That is what that one people like to have that energy in the electrical form there. Anyway, that is what the my just that concern for that is there to share with you that one. Then okay, that some target turbines. Okay, runoff river plants are there. This is the different type. That we talk about that runoff river plants. And then of the story. That I have seen that. I'm not sharing so many that what is there. So with that low head research, a lot of researches are going on in the USA and specifically European countries there. European countries. So that there what that they have come up with lot that experimentation on that one. And of course, always that I have seen that most of the projects are what that of the range of what 30 megawatt, 50 megawatt, 10 megawatt or something like that is there, but not to the level of it is something like 5 kilowatt, 500 watt, it is something like that, 200 watt. You see, 1 kilowatt is more than enough. No, even if it is the 500 watt is sufficient to house, to meet the load requirement of villagers or something like that, remote villages or something like that. So that is the concept of that type of research. It's not much. They are, of course, the design they have come up with it to improvise on the law head one. So same one can extend for that. That is part there. I'll just share some of the parts there. Anyway, so in terms of that storage by facility type, we see that one. What are the facility type? So storage facilities there. We say that one. So this is the first one. Second one is storage. One is reservoir. Is the conventional, the big dam, hydel power station, big hydel power station, the big reservoir with the dam, high dam. Okay, that is what that conventional what we talk about that is there. And other one is what we can have that pump storage in stream, that hydropower, that one is the in stream there. This is that we can. So these two are almost similar, not exactly same there. Okay, not exactly same. The runoff river plant. That means low head. These two are both are the last one, the in-stream hydropower scheme and runoff river. That one, they both of them, both these two, they belong to the low head one. Okay, so that also low head one means one has to go for the reaction type turbines will be there. So there are a lot of developments in the reaction type turbines. Okay. So the runoff river plant also, most of the projects I have seen that one is there. That they have used that they have diverted, then ultimately used some pond is there, pond is what some small pond will be created and which will be fed from the river, main river, and then that will be used for producing electricity. Again it will be at the tail raise, what will be that will be again fed back to the main river there. That is what it is done there. Whereas in stream means what sometimes what that in stream there, you are not going for no dam, no pond base, nothing is there. Whatever water is available, rivers like the Brahmaputra river is there, or some hilly river perhaps in that one is there. Simply used. But hilly river, as I said about that, that they because these people now who are rich guys, their industries or something like the big short industries are there. They want the project in billions. They want the project in billions there, and they are because they are concerned about their profits or other like that is there. But the thing is what, when you talk about this one, the Healy streams and others, it comes in that petty few kilowatts, 10 kilowatts, even 100, 1 kilowatt, 2 kilowatt, something like that is what. Okay, so that type of thing is what, maybe 200 kilowatt or something like that type of ranges will be there, and which will allow you to even cater, 10 villages or something like that is there. So for that type of thing means what, you will not find that much research or not much industrial development in that case is there. They look at how much is the investment I make and how much is the return I can make out of that, how much money I can make out of that. Okay, but of course some as I said about that, some developed countries they are because their requirement also not much there, so they come up with, as I said about their target is what, to separate that, segregate their industry sector from the domestic one there. Domestic one, they want to come up with that is there much more what with the distributed generations there. The same concept, microgrid, distributed generation, all this concept come up for that is there. And with that way, same concept as I said about that picogrid there. Have you seen that? Microgrid, then you can have that mini grid, microgrid, then picogrid, then what is the family grid there? You have a family grid there, that type of level of that one. Okay, so that are the concepts of that. Okay. So anyway, so that okay, pump storage and okay, that this one is what is the spatial one there. And normally what that in most of that that in the developed countries they come up with this one there. This there's a one-time investment. That once this is developed for that one is there. It is a storage one. Like a battery storage. Okay, battery storage is what oh my God. As some of you I heard about that, discussing about that, the power which can be stored. You see, normally what most of the microgrid work, and my students also they are working on that microgrid, generation control, frequency control, what is every case they are using that, battery storage is the common element for that, or you can go for that one that what ultra capacitor or other type of storage elements there. So that is when you start using battery and you just look at that electric vehicles, not vehicles, e-rickshaws. Look at the cost them there. These people, when they're, after 1 or 3 years down the line or 4 years down the line, what happens to the batteries there? A lot of chemical pollutions. Lot of chemical pollutions will be there. Leave aside the charging and requirement of that also, it is always there. So this is one part there, and this is one issue there that is there. So that these people, specifically developed countries, they do not have that scarcity of fund as compared to like countries like India. So they are what they go out for that the pump storage scheme there, where that the pump storage that unit is treated as storage device in the system for that is there. So during what like the light load condition, it will be treated as a what, you have the reversible machines there, same machine which will be acting as sometimes acting as motor and sometimes acting as generator there. That is what is available, that can be done. So that is done there. So during the light load condition, use that this one as a the load which will be running as the motor, and the other type coming up. That is what, this is a very important part of that. That one, because basically it is a hydro plant there. It is a hydro plant there. That you keep in mind that storage is okay, but that you have to see about from technical point of view, it is a hydro plant there. Okay. Okay. So then okay. So I think I should not go for it is the different things. Madam, Srijit, how long I can continue?
Sir, this session is till
5:45.
5:45.
5:45.
Yes.
With including questionnaire, sir.
Okay, no problem. I don't know if the participants they feel like okay, no problem. I'll see that one is there. I can go. This is what I wanted to short some of the things. Otherwise, okay, I can go ahead with that. Okay. So because after whole days that one they also made anyway that we'll see that one is there. I'll try to the stress upon that what are the issues as an engineer in future you come or you start up something like that. So where do you dwell? Keeping in mind that thing is there, and where do you, because you have to start working, then automatically things will come up. You will never think that means, or you will never be an expert engineer or knowledgeable engineer just from the beginning. To work with that, come up with that, face the problems, then understand, of course, revisit your fundamental, theories, different elements, not only electrical, why electrical, all real life problems do require knowledge on physics, do require knowledge on mechanical engineering, do require knowledge on civil engineering. So what mathematics, of course, it is inherent to all engineering, that one. So all of you have studied to some extent, and rest part is what your mind and your trained mind with trained with different technologies there, and you can do that. So that is what I just. So anyway, that these are the different major components of that. Okay, I'll just add that why I have taken this one. It is same as the old one. So what is there in that? No, the question is what. When I say that one is a big, big hydro power project, big reservoir systems. Okay, you have this one is there. So there is a, that this is the, structures of that. Okay, this is the structures of that. Okay, so what can be done is what some of that is you come up with a small. Okay, not only that, I say that one, this is for specifically for high head. This is specifically for high head, that one. High head, this one, hydro power projects there. Okay. Then because whenever you have the high head is there, that is how we say that one, there is a surge tank there. Surge tank, and then rest is what penstock. I think penstock is not, that is what there is support. There is again just followed by surge tank. There has to be penstock, the height of that one is anyway. So the penstock is what, that is the one which that increases that ultimately what that from that particular that specifically surge tank, it goes to that, it directly enters into that that nozzles there. Okay, so that is how, means what, this is the technique one has to learn for that. Surge tank is, it is something like when there will be variations in the load, then there should be corresponding variations in the input to the turbine or input to the generator there. So that type of variations has to come back like this. So that is something like, that flywheel type, that surge tank is there, which will be what, suppose there is a sudden increase in the load. So that will call for the sudden increase in the input. So where from it will come? If you have a big pipeline there from the, dam there, it has to, first from dam, it will come for that through the power channel. First is one, there may be power channel, depending on the length of that one. Power channel does not create head. Power channel does not create head. So ultimate head is coming up from that, after the same level of that, that your that intake structure there, same level it will come up for that. Then ultimately it will terminate with the what, that surge tank there. There will be what, small tank there is some reservoir type which will temporarily store the excess water there, and so that in case of any variations in the turbine requirements, or which is in result of that variations of the load and the variations of the generation input there, there has to be corresponding variations in the turbine. So that part will be temporarily taken care of by your surge tank there. That is what that. Okay, that is what. So anyway, so there is one part, there is a missing part, the penstock. After surge tank, there has to be penstock will be there. But I cannot anyway that. Okay, anyway there. So my question is what, why I am just taking for that. When you go for that, you want to use that, Pelton wheelbase, the impulse type turbine there. You have to look at this configuration, this structure will be there. As I was talking about there, you want to use this concept in the high building there, high rise building there, the 30-floor building there. So where, that here, how much is the volume water head as compared to that, how much is the volume available, and the flow is there. This two means specifically water head and then flow is available. How much you can convert so that that impact will be, the pinging impact will be there on the buckets, the turbine blades will be there. So that has to be. So that is what that keeping in mind that one, what are the principles which are being followed there. All the provisions elements in that one for a hydro power station using that high head with impulse turbine, that should be looked into that. And so the requirement of that one then come up for that, so that you can improvise on that, work on that, given the different situations, conditions there. You may not have exactly similar conditions there. So modify it, which one needs to be modification, which one need not. You have to give that, understand that one. It is your input, your research there. You come out with your observation, that will be worth sharing for that, because others have not done it, as I'm sure for that. Anyway, so this is the different thing there. This is the different, why I have added this potential that I have taken from some Indian, this one, MNRE and other sites there. This concept is what? This concept of the Indus, that one, valley, that one, Indus, that different rivers there, you have that one. So this is the potential given in the megawatt there, that 1,48,702. This is what, this is the potential of what energy which could be produced from these rivers there, different type of rivers are there. Now the thing is what, this is under an assumption. Under an assumption for that, what is the technological possibility of, how much is the possibility of using the water potential available in these different rivers there. Now you see, water potential is one thing there, and conversion of that one in the different way, different method, different techniques are there. That will result into what? That the augmentation, you come up with the same one there. That suppose you have in the Brahmaputra, there will be series of dams will be there. Series of dams, not only series of dams, series of runoff river plants will be there. Runoff river, that thousands, millions of turbines may be installed for that one. So what? So automatically what that will come up with that, it will come up with definitely 2000 megawatt that one. So that is how I say that whatever that, why I have just shared this one is that under the given assumption that what should be the technology, what are the ways to use that, exploit that one to convert this potential into the electrical energy. Under that assumption, this is the potentials which are, thought to be that possible, that one is there, but it will be definitely different for that. This is what you have to keep in mind for that. So anyway, for the law head one is there. Law head one. Okay. Law head one. Okay. Anyway, so that when you come up with a different type of law, okay, this is the different types of law head turbines are there. Axial flow popular turbines already is, it is used in that different foreign countries, and it's already done in the different projects. Many of these are used in the projects only. Prototype models of projects are there. Some of these are used in that one. Some project there. Of course, these implemented projects are there. So specifically, what that. So these are all what law head. All are law head. Just like that. You see that each one is given for that is there. This is actually for this is a propeller turbine. This is also a type of. You just see that one, the choice is limited for, radar up to the 3 meters, law head. This is also law head there. Okay. 3 meters. This is basically is the bulk type, that above 3 meters above type offers there. The bulk type turbines also used for that is there. There are, modifications in the bulk type turbines there. Earlier people used to, refer for that the law head turbines, as I said about the runoff river plant, they used to use the bulk type turbines there. Okay, so then they have done a lot of experimentation with the bulk type turbines there. Then they came up for that some of that losses are there in that one. They tried to reduce the losses there, specifically because of the frictional losses and turbulence also that one is there. And then they have come up with that. This is one of that one is there. Axial flow turbines there and tubular turbines there. This is one type of that one is there. So. Only was that because that most of that the law head turbines, the problem with what the speed is not very high. Speed is not very high. That as I said about that is there to come up for that Pelton will the high head is there. Speed will be quite high there. Okay, whereas this type of machines there, that turbines there, speed will be low. Then how it can be used for that? So for the low speed. Means we generation electrical energy conversion into electrical energy is what with the electrical machines that become again challenging one. So what is done in this case is what they use the gearbox there to increase that speed, so that like we can come up to that that range of the speed for the where at least what efficiency ensured for that possible, specifically for the electrical generators there. Can be done. We'll just see that one as we go for that switch over to the electrical side. I'll discuss about what are the issues for that coming up for that for this type of situations there. Okay. So tubular turbine, there are 4 types. There's the Kaplan, propeller. This is already that semi-Kaplan part also already used for that because with the adjustable guide bands and propeller, that one is being used for that. A lot of the projects there, specifically in the USA and Germany specifically. This is, I've just taken that, I have picked up this one from there just to show that what is the bulb type turbine. That is what we see that. What is the bulb type? Why it is called bulb type? You know, it shows that something like that, you know, that is like a bulb, you know, that bulb which, you know, that which carries that your whole that, you know, electrical part there. You know that also that you know, electrical component should not be immersed or should not get wet. So we know the electrical machines and other components should not get wet. So that is how we see that one. So at the side of this is what the bulb is there, like a bulb is there, and you have the turbine. So turbine is out. So ultimately water will be flowing through that one outer periphery of the bulb is there, and it reaches to that. This is a reaction type, that one. This is a reaction type. There is no bucket shape or something like that. So this fins are created so that, like, you know, through reactions, pressure is converted into the kinetic energy. Okay, that is the concept of that. It comes off, that is there. But initial that bulb turbine was having a lot more, you know, that efficiency improvement was very, very limited for that, because of that, you know, you are using the bulb here. So that directly for that. So the flow is coming and then it's diverted, then comes off for that way like that. So there were a lot of, you know, modifications in that they have come up for that. Different type of, you know, that is how you come up for that. This is what that through that channel it has come up for, that is there. So that is a split into that one. You have that instead of, you know, one side, this one they have come up for that the two ways of, you know, input to the turbine there. So that ultimately what the rotation can be, or higher rotation, so higher conversion efficiency can be achieved for that. Anyway, this is okay. These are the different ways. There's the modifications, and there are different ways of modifying that same low head is there. Simply you see that the head is low. There is no height of that one. Through that one you make that, you know, that that increase that in the pressure, so that like increased pressure gets converted. Higher pressure gets converted into. It is what I said, that one can increase the pressure, then coming out with that, so that like higher pressure gets converted into higher mechanical energy. This is the concept of what for that all that type of reaction turbines there. Anyway, this is what the furnace do is there. This is UK people that have for that is there. You know, that the unit size is, you know, there's up to 10 kilowatt to even 15 kilowatt there till now used for that. Efficiency is about 45%. Just not in that. You see, efficiency is you know that okay. Similarly, the efficiency of an STO, that engine, that is also 35% there. You see, the question is what that okay. Lot of work, there are a lot of works going on that, like same is the case in case of solar cell also. If it is very poor, to even 15, 16 to very less than 20% there. So, but the thing is, what once you install it there, there is no running expenditure. There is no running expenditure. That is the main concept for that is there. And the question is what, that having 10 to 15 kilowatt or 20 kilowatt, 2 units there, you have 30 kilowatt or 40 kilowatt. Then you can cater, you know, that remote villages which is having 10 you know, maybe you know, 2 or 3 villages having, you know, at the most what 30 to 40 or 50 families there. So what is the point in, you know, taking that conventional energy, you know, grid to that and coming out with that? There is the use, you know, expenditure, not only the maintenance, the maintenance has to be also looked for, that is there. So that is how there's the concept of coming for that. But the thing is what, there is continuous efforts to increase the efficiency of this type of turbine there. As I said about that, so many varieties which has come up for that is the variation. Just looking into that, then coming up for that, so how looking into that principles are there, they have tried to come up with that you know, more efficient varieties of the turbines there. Okay, so this is again, this is a very, you know, as I said about that, you know, that very highly talked, as of now, highly talked turbines there, which is called velocity head turbines. You know that velocity head turbines, it doesn't require any water head. 0.12 meter of head, or actually basically these are the turbines which are required for part, you know, that for producing electricity without any dam, and you have to put it. That is what I was telling you about that. You have that, you know, that the Brahmaputra river is there, even not only Brahmaputra, but Ganges, and even so many other rivers are there. During high, you know, rainflows and other like that is there. Come up with that seasonal period, because this type of turbines, you know, that this is so, you know, easy to install and very comfortably install it very fast. one can install and dismantle, transport it, again come back like that. That is how it is there. Use. This is so much, means within few days to weeks, you can install it there one after one. That's what I said, that one, you don't care that barrage is there, dam is there, nothing is there. Simply have some solid structures will be there, some structures will be made, some steel made or something, some structures will be strong enough to support the turbines there. Series of, it is something like, that wind in the USA, you will see that one is that, 1000 megawatt windmill is there. At how they have come, 1000 megawatt windmill in USA, it was made out of 1000 turbines. Every turbine was having that capacity of 1 megawatt. Now how this, for this type of situations, you have to have average wind, high average wind velocity, and not only high average wind velocity. First requirement is what you have to have the space where this 1000 turbines can be installed. Again, it is not that turbine installation cannot be just like arbitrarily. There also what, when you use the 2 or 3 or even 10 turbines in a series there, then that the effect of speed of the wind velocity will be affected for the subsequent turbine that will get affected because of the previous interference of the previous windmill. So there has to be minimum distance between the two across, as well as the one direction, both the directions there. So that like means what, the disturbance of one turbine to the other one is minimum. That is how it, same is the concept here also. You come up with the thousands of, here it is not one, the thousands of units will be there. Simply install it there, and dry season simply dismantle it, take it there, and again go back to some other place. Who stops? The question is what, you are getting 1000 megawatt for rainy season, 3 months, 5 months, 6 months. Who will give you the 1000 megawatt multiplied by, see that how many hours will be there. If you say of that 3 months into multiplied by 3 months, 30 days, then 3 into 30 days into the 365 days, 365 hours. See that how much is the megawatt hour will be there. Who will give you that? So that, of course, that in our days, in the very old days, 30 years or 35 years back, it was definitely in a daydreaming one, because the problem with this type of that, okay, it is well said. Somebody says about that, I will come up with excellent, efficient microgrid, smart microgrid. Baba, karke to dekhao. Are you come up with this very small microgrid, implement it, demonstrate it, so that what to the level of that it is what 10 megawatt. Forget about 10 megawatt, 1 megawatt also. In our institution, there are 2 megawatt that no solar, that one is there, and I have doubts how much of that is being utilized for that. Okay, that may be there. One may be customized, that come up with the solutions will be there. So my question is what, that you have this whenever we have those days, in old days, you see, I'm talking about these days, but when I refer it to the 30 years back, 20 years back there, when the power electronics was in infancy stage, very nascent stage. There's so much undeveloped. You come up with SCRs technology, and then come with switching of that. So many SCRs in series parallel combination, then coming out with how to ensure for that perfect parallelism among that all the SCRs, then again that in series, then come up with all these issues will be there. Then switching of that one is there, how to control that one, that the different, all the issues will be there. Whereas as of now, that because the development in the power electronics world technology there, it is not only development in the form of what, convenience, in the form of efficiency, in the form of capability, in the form of very important aspect is what, stability. You see, 20 years back, we had SCRs. I also used SCR 25 years, 30 years back. But the thing is, there was no guarantee that how many days that SCR will give you that, services. So it's the first requirement. You see, electrical engineering, that concept is, it is not that you give it for 3 days, you give it for 3 months. But if you miss it for even 1 day or 2 days, or when it is urgent necessity, nobody will look for that. Simply ask that, go it out, we'll come up with that solution which can cater our even urgent situations also. So that is how that one is. The first thing is, those days it was, we could not think of that. We knew the technology, we knew the principles there. But the thing is that you see technology development, it cannot happen in over few days time there, over short period. It never happens. It takes time. One has to wait for that when that hardware development, technology development comes up to the level, then you come up with a different type of solution. So what is the solution possible today? 10 years down the line, solution is supposed to be better. It has to be upgraded, keeping in mind that the development of the technology and which was not possible today, which is not possible today, maybe probably after 10 years down the line, 15 years down the line, it will be possible. That is how my concept is there. Okay, so that is this type of velocity had the turbines. A lot of that is what I said, that what is there, the USA, California, USA, that one two system concept that was the use for that, the adoption for it. That these two systems were that the last line the concepts developed in USA were considered for adoption in India. That while doing this one, that is what I wanted to share for that is there. We have added a lecture on the Make in India concept or something like that is there. So that one says about that is there. This one says about that. Oh, it's too much for the mechanical side. Oh, better I'll just skip that. Okay, I'll just touch on that. This part is there. So that there are so many things available which are available in the developed countries there. You just bring in the technology there. And the thing is what, that under the conditions it was designed, developed, and the conditions where you want to apply for that, that will be different. How it has to be adapted for that. Another one is what, that continuity of supply, the standardization. Standardization is what? Why standardization one look for that is there? First and foremost requirement for standardization is what? That the continuity or availability of the component. Availability of the component. All over the world, everybody uses a particular standard. So you use that, you just use a machine, one screw gets damaged, one bearing gets damaged, balls gets damaged. So if it is as per the standard, then you can buy from the market with that standard everywhere. This is what availability. Other one is what, cost of production will be very, very cheap, very, very less, because that you become a customer for that same product, which is meant for that for some company of USA or even Indian company that who manufactures for that one, that customer will be from US or other countries there. So you have market becomes the global market there. It comes in the billions of customers there. So ultimately what same infrastructural facility used for producing billions of units there. So production cost per unit will be very, very less. So one is the production cost, other one is what, compatibility, availability. These are the issues that are there. Okay. So keeping in mind that now the question is what standards are made as per the requirement of the foreign conditions there. How then can you adopt that one for Indian conditions? Yes. There is again engineering technical concepts. One has to look into this. There should be some innovations. Just come out with some innovations which will make that which will create an adaptability between these two parts there. The Indian conditions, then making that other one is there slightly so that can be adapted for that. This is a very important concept which comes up now because of the Make in India concept, means India is allowing for that so many technologies are being adopted for that from the developed countries. Anyway, this is what I say about that. Some of that one which is used, as I said about that USA developed in that USA for that, which was adopted in India for that. The same type of that one. They are installed on on reward or something like that is there. Simply the structure is there. Put this one or there maybe you see that is what my logic is what. This structure is what it is kept in mind. This design keeping in mind that soil conditions and conditions of the rivers of the USA one. So what is there? So machine is same. You use the same machine there for Indian conditions. You come up with a different way of structural variations there. Innovations in the structure, innovations in the other way of the fitting of that. But these are the things there. So that is how that. Don't go for the blind adoption of that any of the technologies there. That is what that. Anyway, so I think that okay, I had given okay, this is the different projects which are installed in that. Recently or is already installed in Nagaland there. That I wanted to share with one of the project, pioneer that one, that worker in that micro hydro project there, did tech from Roorkee University those days, come back there. there was for the alternate hydro energy center. So he did MTech from there. After that, he came to the Nagaland. Was basically from Nagaland. So he came up with lot of turbines with that, with the bamboo made. Bamboo made this one. As they made that one is there, and he used the turbines. Some of the turbines for of course, it is now almost 30 years back or 28 years back. I think I was trying hard to get one model for our institute those days. That was the case. So anyway, this is what, I have just looked into they have installed this one, 2 into 50 kilowatt power 3, about that. That is 100 meter, and then penstock length. Just the penstock length means what this type it will be. Penstock length is then cross flow that over that type of that. So you have that much length and you have one, but there is what that higher height there, but you are not going with the impulse, you go for that again. What in reaction type is there. So there is nothing wrong. It is what just crossing of the different techniques and methods there. Ultimately, the objective is to enhance the principle. Where are the aspects which goes into the negative, way of that, decreasing the efficiency. So the look for that, so that one with it, increasing efficiency. Just look into that. You see, you can come up with paper or something. There is a just that type of technology there, and you use the small experiment that one can come up with that also innovation. Anyway, so what I said that that these people have shared any of generators and other they have used for this. They have not know this is what same one the 250, this is 100 kilo, 250 kilo. This is so much less power that one is there. Okay, this is what they have come up with that. Of course, this is not from that, not off the shelf from that what is there. Anyway, this is what okay. This is a different same that. Anyway, this is the different type is there. Okay, now I switch over to the electrical part there. Anyway, I'll see that. Why I was stressing the mechanism so much that I want that you come forward with that. People to come forward for that. I did 30 years before, 25 years before, as I told about that, I was very much eager to participate with that person, invite that person. You come from and later on he was having so many projects, so many social projects coming out with so many like that. So I was, of course, those days it was REC days there. Anyway, but okay. So for the electrical machines there, just try to capture the different aspects of the machines there, which are being used as different type of technical issues there. Anyway, so I'm not touching about that shunt generator. All of you know that, of course, you have to understand that principle of shunt generator, DC shunt generator. This is compound, is a complicated version of that is similar that one. You have the more facility, series and shunt combined together. You have that DC shunt. Okay, so DC shunt machine is what which are used in the micro hydel stations. Micro hydel stations. So one can use for this one. This also can be done. The problem with DC machine is what that they are having that brasses and the regular maintenance is required. So that is the main problem with that one is there. So that is why that people switched over to the AC machines there. And the AC machines basically what? Even other day while giving lecture, I was talking about that. I was giving I was talking favoring that synchronous machines. Okay, as compared to the induction machines there. And so one of the participants asked about the question about that. Normally it is said that induction machine is considered to be more rugged, more rugged. So that was the question. So rugged, what is the meaning of ruggedness of the induction machine, and what is the meaning of the efficiency of the machines, the AC machines? That these two things are different to some extent. That. Okay. Anyway, so we go for that. That I'll say about that straightforward. I'll go for that there. So these two machines are there, the synchronous machines and then induction machines there. So normally, what synchronous machines are doubly excited machines there, whereas the induction machines are singly excited machines. Same is the case with in case of DC machine. DC machines also doubly excited machines then. So all doubly excited machines are more efficient. You see, ruggedness is different. Why induction machines are considered to be more rugged, specifically in the squirrel case that we go for, that is there. Once you design it there, you don't have to look for that, for next 25 to 30 years. Forget about that machines and it will keep on giving that one. Because it is what, it doesn't have, any other part other than like the DC machines there. So it has nothing to do for that. It is rugged in the sense means what, that it doesn't require any maintenance. It doesn't require any maintenance. Okay. So that way, it is called that one. Or specifically, squirrel case type. The squirrel case, the rotor is what it is. Simply is what it's the casted type. So it is strong, more rugged in the sense means what, nothing is going to happen to that one because of rotational, because the rotating machines there. Whereas in the slip ring type, it may come out with that if there is a high speed variations and other way like that, rotor windings may come out because rotor is running, so rotor winding may come out some part or something like that is there. Whereas this is not the case in case of squirrel case machines there. So that sense mechanically it is stronger there. It is rugged in the sense is there. Construction point of view it is rugged, but the energy efficiency point of view it is not efficient. It is not efficient. Okay. Because whereas in case of doubly fed machines or DC machines as well as synchronous machines, they can be made more efficient. You have to keep in mind that they are efficient in the sense means what, as they're doubly excited, they can be made more efficient. Why? Because you have the field circuit is there and you have a what, armature circuit is there. So these two circuits can be designed in a decoupled way, and then ultimately what, just see that one is the every circuit is designed to achieve its optimum or maximum, objective there, or we can say the maximum to maximize that objective we say about that is there. Same is the case for the rotor circuit also is there. Whereas in case of synchronous induction machine, it is for the power is flowing from, in case of motor it will be from the stator to rotor, where in case of generator it will be rotor to stator. So ultimately what, the power exchange takes place from same power. Suppose I say that one is the what, that 5 kilowatt power supplied to the stator will be transferred to the rotor through air gap. So that because the electromagnetic, induction is there. So electromagnetic that linkage is there. So electromagnetic linkage, that also electromagnetic linkage for that induction machine is what that through that air gap. Air gap is of having high reluctance. So because of that, its permeability is less, and so ultimately what, the energy efficiency goes down. How can you increase the energy efficiency? Just simply decrease the air gap. Now the thing is, there is a limit. There is a limit for out with what, so to reduce that air gap there. Because if that gap is reduced too less, it is something at 2.5 or 3 millimeter thing like this. So if it is too less, then initially after the design 6 months it will be working properly. But after what? After 6 months, there is a what, the ball and bearing will be there. Some balls out of suppose over 200 or 300 or 500 balls are there. Some ball may get decayed early. Then other balls are there. There will be misalignment of rotor because of uneven balls surfaces there. Ball periphery there. Bearing ball periphery. So that is ultimately rotor will be inclined, then it will be touching on the stator there. Okay, this is what these are the issues there. So we cannot. So there is a what, that concept keeps up that one is efficiency wise, energy efficiency part. The coupling is very, very poor as compared to that synchronous machines where we just got separately, it is gone enhancing. Whatever the limitation is there, we can separately enhance the magnetic field strength. Go for, because the electromagnets, go on enhancing for that to take care of that what is there. That is possible in case of induction machine, synchronous machines there. Okay. Then another one also concept is what, that is what, okay, maybe relevant, I don't know, that is there, is, when you go for that idle power station, you have that high head idle power station. It is not high head, that for idle stations, we use what, we use that one, what type of generator, it's of course synchronous machines there. What type of generators are used? Some people will say that one is the salient pull generators. Why salient pull generators? Why not cylindrical generators? Where are the cylindrical generators are used for that? then we come up with that one thermal stations there, thermal steam-based power stations there, and there are so many that concept. Why it is called turbo generators in steam-based or something like this type of all the issues will come for that there. But specifically for that, it is not. What is important for us is what that whether you should go for salient pool or what to go for cylindrical type. The first one is we have to see what is the speed of the what is the RPM turbine. What is the RPM of the turbine? Okay, so in RPM of the turbine, we know that we have to make 50 hertz electrical energy there. Electrical supply is 50 hertz. So if the speed is less, then how can you make that the frequency has to be 50 hertz? How we can make that? Means it has to complete the 50 cycles, electrical cycles in 1 second. 50 electrical cycles in 1 second. So we go on increasing that. We have to increase the number of poles. How can you increase? This is one issue. We can increase the number of poles, then automatically electrical frequency will go on increasing. Right? There is no that electrical. We can the speed will be increasing. Physical electrical speed will be increasing for that. It is something like that 2-pole machine. Okay, it is mechanical speed as well as electrical speed is same. 2-pole machine there. If the rotor completes 360 degree, then it will complete 1 cycle. Similarly, electrical also that voltage also will complete 1 cycle. But if it is a 4-pole machine, then what will happen? Mechanically, it will complete one rotation in the electrical, it will be 2 cycles. So like that, you go on increasing the poles. So automatically, what electrical cycles, the frequency will go on increasing like that. So you see that one, the formula is the 120 F by P. Oh my God, that formula is, forget about the formula, that is okay. That will be helpful, but you have to understand the physics. You have to understand the physics there. So we have to increase the number of poles. So if it is a cylindrical one, then that cylindrical periphery has to be there. Suppose we want to add, suppose we say that one is that 50 poles are there, okay, or even 100 poles are there. You have to understand that also. Why the poles are again made even number? Why you cannot have odd number poles? These are the issues. You have to understand that one. You have to ask yourself and find that. So when we say that one is what still is, even number that one, suppose 50 or 100 poles are there, it has to be made. So 100 poles are to be accommodated on the periphery of that, on the periphery of the rotor surface there. Suppose it is cylindrical one. So you understand that what should be the size of the periphery of that rotor has to be made bigger one. Otherwise you cannot accommodate 100 poles there. Whereas in case of salient poles will be mounted, only base will be connected with the rotor. So we can accommodate more number of poles in case of salient pole machines there. We can accommodate more number of poles in case of salient pole machines there. So they are very useful for machines that just look at that what is the RPM speed. The moment you see the RPM speed, you have to go for salient type. Okay. Otherwise, okay, there is a question there. Okay, that is one part there. You have to keep in mind that the question of 50 hertz is important when we have to connect our generator with the conventional electrical grid. If our electrical generator is not to be connected to the grid, why we are considering 50 hertz? Why? Who stops you in using some other frequency there? Who stops you in using some other frequency there? Okay. So, okay, now the question will be that means what we know that means our household appliances are 230 volt AC and all this. That is okay. That I'll come back to that again. That one is a different part there. Okay. So okay. So what happens here that so we go for this is one issue. The technical part is there. So how to the requirement of low speed requires more number of poles, which calls for that salient pole. Now the thing is what? Then why not we use salient pool machines for the steam turbines or steam power plants? The speed is 30,000 3,000 RPM, 3,000 RPM or 6,000 RPM. How do we use for that? If we use that one, that because if it is a the salient type machines there, that poles will be mounted on that pole rotor body there. So ultimately periphery will be quite large. On the tip of that, from the base to tip of the pole and across that whole periphery there, then the base will be, ultimately periphery will be, at almost 3-4 times, okay, 5 times more than your, even 10 times more than your cylindrical one there. So ultimately, that centrifugal forces, that is what inverse is directly proportional to the square of that one is there. radius of that. So ultimately centrifugal force will be so high that simply that your ball bearing and everything, they are even poles also will be coming out from there. There is another technical issue, the mechanical issue for this. First one is electrical one, second one is your mechanical one. Anyway, that is what there. So we go for the salient type of this one is there. Okay, so sometimes what that with renewable sources that that nowadays the trend is using that permanent magnet synchronous machines are also very much used for that. I have seen for that. Yes, that is you, because as of now it is possible you use that any type of machines there, but that any other technical issues that can be handled adequately and efficiently, effectively with the introduction of power electronics devices. You have a converter, invert circuits will be automatically that will take care of that. Any of that compatibility problems that can be addressed to that. That is possible as of now. It is very conveniently can be done, cheaper, efficiently that can be done. Okay, so as I said about that squirrel case one, because this also is used for that. In the most of that, that as I said about that. Squirrel case, as I said about that, there are two type of use of that induction machines. There is a generator. One is what grid connected induction generator. Other one is a self-accelerated induction generator. Anyway, that I'm not going for. Okay, and the DFIZ is there. DFIZ is okay. Own rotor. That one there where we talk about that. Variable type is widely used in specifically in the wind turbine, and specifically in that turbines which are having up that as I said about the low head turbines what their output will be very much variable because of the variations of the flow. Suppose river is there, river flow is never constant, whereas you have high head hydro, big reservoir hydro system there, you have the constant speed is possible there, because you have to maintain the speed is there, head is continue flow also. All these two issues can be ensured for that. So that is why the constant water head, that one, and constant speed, that one is there. Whereas in case of this one, so constant speed you can come up with the synchronous machines there. Okay, so which will have the once you designed the speed has to be constant, and then so that like your frequency has to be what constant there. Whereas in case of variable speed, you cannot use synchronous machines there. It can be used. It can be used. How it is they again go for converting into that means the converter, then that AC will be converted to the DC, then use the inverter, then come up with the AC there. Okay, that is a different issue there. Then you come up with that, that 1000 megawatt, 2000 megawatt, 3000 megawatt in a converter and that power level. Just imagine that. Simply that addressing to that complication for that is there. Anyway, so that squirrel case, this grid connected induction generator and self-accelerated induction generator, which was normally used for the earlier, most of that, the micro hydel and then mini hydel projects also. I've said that long back that in Tripura also there was one thing that it was long days back, our student days there. They used that self-accelerated, not grid connected induction generator that was used for that. And self-accelerated induction generator, the later on addition for that is there because of that lot of burden of that, the reactive power burden on the grid because of the induction generator, because induction generator cannot have its own reactive power. It has to have reactive power to support its voltage build-up system there, and so that it can act as a generator there. So it absorbs the reactive power from the grid and feeds active power to the grid there. That is the case is there. So that is why that people say no, we'll go for self-accelerated one. So sometimes what the remote locations, as I said about that islanded locations there, where conventional grid could not be extended for that, then people went for that induction generator, but in the self-excited mode there. The own rotor type is there. That one, the DFIs is the one, the variable speed that's widely used for that. This is also nowadays used for that. That one is there, and lastly, okay, that it's not. This should be what there is a BL decimation. The last one is there. I'll just talk about that BL decimations also. Okay, okay, this is self-excited one. This thing many of you may be knowing that one is there. This is the generating mode. This is generating mode, the grid connected one. So grid connected one means it has to act as was super synchronous. That S has to be negative for that. How to make that is that you have to make the rotor speed higher than the synchronous speed. Rotor speed higher than the synchronous speed. So we can do it by making the synchronous speed less. Synchronous speed means not frequency. You have to understand that synchronous speed less means what? Synchronous frequency remains same, but the ns becomes 120 by f. So it just number of poles will be changed automatically. Ns will be changed. So make the ns different so that like your ns becomes less than nr. As that so long as ns becomes less than nr or nr becomes greater than ns, the machine will be acting as a generator. Okay. Otherwise, what you have to overspeed the machine. So turbine has to be overspeeded. The rotor has to be overspeeded. But there is a limit, means one cannot go beyond theoretically 25% more than the rated one is there. Okay, so that is what they. So safer one is what they go for that 10% or 15%, or that is what. But theoretically more than what this. Anyway, that is part there. So this is what self-excited one, where the islanded one is there. The islanded mode there. And you have wind turbine, or same is that one, your hydro turbines will be there. It is not wind turbine. So it may be a hydro turbines there. Same one there, hydro turbine there. Okay. Then you have to, the speed low, as I said about that in the current conditions there. Some of the law had that one. The speed is low, use the gearbox there. Normally gearbox is what, depending on the ratio there. If one gear ratio, then you have the 1% reduction in that efficiency. If the 2 gear ratios there, then the 2%, like that means what? There will be, you go on increasing the gear ratio, so that the speed is increased. Then at the same time there will be losses because of gear, higher gear ratios there. And then see of that one is how much is the improvement in the efficiency of the generator because of being it is run at higher speed. As I said about that, when you design a generator, the machine is there. So you design a generator for a given speed there, rated speed there. The rated speed is what, quite higher than this will be there. Quite higher than normal, whatever speed is available for that is there. So because of that means what there is a requirement of that enhancement of this. Suppose you design that one. Okay, now the question again, you ask me that one, why can't we design a machine generator there for low speed? Yes, we can design a generator for low speed. But the thing is, in that case, that size of the machine has to be very big. Why? Why size of the machine has to be very big? Because you have what, the speed is less. Speed is less. So induced EMF is proportional to N d5 dt. Okay. So what you have to do is the N is fixed is there. Okay. That so speed is d5 dt is what it is depending on how much is the variation of that flux is there. So as the d5 dt is low, as the speed is less, so how we can increase that one voltage by increasing N or by increasing phi. So if you want to increase phi means what, then the size of the machine or magnetic field strength of the machine has to be quite bigger one. Field strength of the machine has to be quite bigger one. Size will be quite higher that one. So these are the issues that, okay, that you have a machine, bigger size machines, the inertia will be more. Inertia will be so much higher. So you can have the bigger size machines. The rotor inertia itself is what, it will be at least 30% of that your load is there. Then, so these are the issues will come for that when you come of the design of any generator for a given generation system. Anyway, so three-phase, that concept that comes, the capacitor banks were used for that, so that it will take care of that your excitation part there. So no reactive power requirement from the grid is there. Anyway, so this is normally used as all the squirrel cage machines are used as self-excited induction machine. Why that? Because in the squirrel cage means what? In case of very for this type of machine is what that the for the rotor as well as what the rotor should be similar. This is the requirement of them. Okay, this is the requirement of that. So winding in the stator rotor to be similar for that is there. So because of that, you have rotor windings there, stator windings will be there. There will be corresponding similar induced that rotor windings will be there, which is what on the your rotor body will be there. It is the induced circulating paths will be created for that as well, corresponding to that whatever the stator currents will be there. So stator currents and stator flux will be there. So specifically what this is what I said about that. This is very versatile, is widely used for that. Why I do not wrap up for this is there. Why it is there? Because it is, first thing is what I said, that is the induction machines are inferior from the as energy converter as compared to double effect machines there. This is one first that for technical disadvantage that one is there. And another one is what very complex one is there. Can you use this type of systems for, as I say, a 10 kilowatt system, 20 kilowatt system, where you have the complicated one and you want a person there who will be for the maintenance and controlling of all these things. Once installed for that, something goes wrong, who will go for that? Part there. No, that is not preferred in that case. Yes, you can come up with that where the accessibility, easy accessibility is possible. It is allowed, then you can come up with that any sort of troubleshooting and other can be done for that. So that is why I say that one is the BLDC is the ultimate this one. So a lot of work in the USA and other places it is going on for that. BLDC is made to used as a generator. BLDC as a motor is already established fact. BLDC as a motor is established fact as compared to induction machines. BLDC has proved to be very, very efficient there. Very efficient. Okay, that may be okay. This is what, as I said about that, I used to share that one is the earlier one. So based on the RPMs, you just see that one is there. Based on the RPM, when you come up with a low speed, low speed RPM there, that the wattage of the BLDC fans, that is 5-star fan, and then this is what there. So it is a normal ordinary fan there. The for 140 RPM, that BLDC fan requires 3.8 watt. Whereas 5-star fan, we say that best energy compliant fans there as of now, that is 13 watt there, and this one ordinary fan is 14 watt, quite closer is 2 watt. Then when you go for that 220, that one RPM, then what it is 7.7 and this one is there. So there is a what quite comparison between what as the low speed is there, that you don't get any benefit out of 5-star or 1-star fans there. That means what you are paying 3-4 times higher than that one is there, whereas you are not getting benefit out of that lower speed one. Then as you go for higher one, then okay, you slowly derive better like that is there. Higher speed one there is what. Whereas in case of what with the low speed machines there, you see that phenomenal savings in that power requirement for that is there. Okay, that is what there. So it's just other way like that is there, means what with this much RPM there, whatever the equivalent that one is there, you can come up with that same type of that. So that shows that efficiency of BLDC machine as a machines, it is already as a motor, it is already proved for that there. So that is why the BLDC fans are almost, it is used many of the household appliances for that. Then in near future, not very far, near future, most of our household fans are there. As I said about these fans are there, they will be placed with BLDC machines like BLDC fans are there. Okay, and as I said about that is there. Okay, that most of that recent days you will find go to the market, you will find out that what is this one, this AC is there. What is that? It is inverter, the digital one, inverter based than AC is there. What is that? Washing machine is inverter based. What is the freeze? It is inverter based. What is this? All this type of new gadgets, appliances are what they have replaced the conventional, the single phase, induction machine as a compressor that are replaced with BLDC machines there. BLDC machines are there, and what you can do is you can control it because it is a DC form there, so you can control it depending on the requirement. The controllability is very, very easy for that. Whereas in case of induction machine, if it is the AC part is there, once you use that, controlling itself is what a lot of complications are there. And not only that, inherently that the machine becomes less efficient, energy efficient, less. So ultimately, what it absorbs more power. There is today's recent days appliances. What even that one freezes and then ACs and all this. They are is almost what the 60-70% they are claiming to have reduced that energy requirement. This is one. Other one is what they go for the depending on that requirement of the ambience. They gone modifying the speed of the ACs there, speed of the freezers there. How many people are there in the room, depending on the automatically speed will be adjusted. Automatically, it will sense the temperature of the room. Automatically, it is like IoT based that one. So many. Not only that one is the microcontroller control that so simple that I have seen my that one is also it is like there is a simply you have the control card is there and microcontroller makes the controlling is there. Very so simple that you have a sensor, it will sense the room temperature, automatically it will adjust the speed is there. Same is the case, you have the freeze is there, then freeze there is a sensor for that depending on the how much is the increase in the temperature, and that will depend on the what are the things you put into the inside the freeze. What are the quantities, what are the things at what temperature, what are the requirement, automatically it will adjust for that. That are the one, this is the one. So what I say is what you come up with that foreign that USA already and just Germany and UK also they have come up with that using the BLDC machines for micro hydro level, not micro hydro, pico hydro level generation for that. And we should not be laggards. We should not be laggards. Then other day I was talking about that one, why one should not come for that, coming up with that infrastructural facilities for development of the conducting experiments for that type of thing. It will be, that is a lot of contribution to the society for that is there. Not only the tangible, and you come up with 1,000 billions of this type of units, then it is something like, drops after drops, an ocean like that is. That is how the concept is there. Why you always think that and the thousands of crores, what is that is there? Our requirement is not, societal requirement is not much is there. And whole that, that whole the course is what that is the objective is, mean to ignite and sensitize the people about that one, the way we look at our requirement, the way we look at our lifestyle, the way we look at our concept of the comfort, the way we look at our convenience. All these things should be, looked at that one and should be integrated in a holistic way. Okay. I think okay. Oh, just let me finish up that. Just share for this one is there. Okay, 1 minute only. I think as many of you may be knowing about that. You know that Wangchuk is what? It is relevant for what? Can anyone tell me? Who is Wangchuk and how is he relevant? Can anyone tell me Wangchuk? Wangchuk is relevant for that, that innovation, innovations, which was the main theme for the film Three Idiots. Three Idiots was conceived, from that your achievements of this one, looking at this person there, that the Sonam Wangchuk is there, the Ladakh is there, this is what that. He has come up with, that solving the water scarcity in the, Ladakh. You understand that? It is ice-capped mountains will be there. And you have many areas, there will be the barren lands will be there. Why barren land? Because there is no water. Because there is no water. So you just go Antarctica or many other places. There's so many, specifically developed countries there. Almost 6 months, 5 months, 6 months, 7 months, they are under, ice capped that's conditions there. And there's first and requirement is the first thing is what, how to come up with that one, how to make the barren lands fertile. He was the first man to come up with that is the what that he has created the concept of ice stupa. Ice stupa. That is what you see that the stupa kriti, that one, the ice is gone for that is there. The concept is what the story is that many of you will be knowing that I don't want to go for that is the what. Why I have to say that? That he was an engineer there, and this story tells about that one is there. When he was about to pass that, Wangchuk is there. One day, how he, that which incident that made him to think about that, come out with that ice stupa concept there. Okay, when he was coming back, returning to home, that he looked at that some breezes there where that ice were, touching on that, hanging on the structure of the breeze there. And after some time, he saw that one is that water drops or that ice were getting melted. Ice were getting melted there. And not because of the sunlight, because that ices were on the bottom of support. So the sunlight was not falling on it. So now my question is what to you people also, how many of you people ever, felt eager to look around when you visit, or not only that same place you visit for that same condition you visit for. How many of you just look around and see that where is something different or whatever the way? It is a new way of looking same things there that resulted into the innovation. Innovation is this one, this type of thing. He is one of the, that he has bagged so many awards across the world, and specifically developed countries where they have a huge amount of ice and this problem is there. You can come up with what, that waters, that sources for that drinking waters for that. He has made it now. Ladakh is what, having that one is the fertile lands. He has converted the barren land into fertile lands. That is what that I would like to share for that. Hope that is what I could touch upon your heart and mind, so that you just, from now onwards, we can go ahead with that one. We have reached to the almost near of the end of our that one is career there. And only at the most what I can do is what I can share my experience or something like that. When you land up with some problems or something like that, we people like me, we are there to help you out. We are there. I have nothing to get anything there, nothing to gain, nothing to get anything there. Only the thing is, okay, you will have people are supposed to experience a lot of hiccups. So what? So what? You take up that challenge and that things will. Do you think that it is something like concept is something like that means what? You approach a person there and if he reacts negatively, does it mean that you should not approach to second one or third one? Because if the reaction is negative, does it mean that everybody is negative? No. You look at that, what is your objective? If your objective is more important than what the negative response of the other person there, you will find, look on that one, keep on trying for that, you will find some person who will come up with a positive reaction. That is my motto. Thank you all.
Thank you, sir. Thank you for such a wonderful talk. We had learned today many things about hydro and tidal, types of motors, types of blades in a very elaborate way. Now, I would like to request the participants, if they have any questions, they can unmute themselves and ask directly to sir, or they can post their questions in the chat box. Any questions? There are many applauds from the participants for the lecture. I think that itself describes that it was a very informative talk. If there is no questions from the participants, we may conclude the session.
Yes.
Is there any question? Okay, so I think we will wind up the session here and conclude it and call it a day. Thank you, sir, for your wonderful talk. Thank you, sir. Thank you all for joining.
Uh,
And